start. Balancing equations is one of the hardest and also one of the most enjoyable things to do in chemistry. And I'm not going to do it again. Today's going to be the last session. So what I'm going to, in terms of balancing equations, you are going to do it again. I'm going to do it again in year 10. I'm going to do it again in year 11. And the reason I like to do it early, some schools don't. Oh, thank you, Hannah. Some schools don't do it till they're in year 11. I think it's just too late. And year 11 struggle. About 90% of year 11 struggle with balancing equations. Oh, I just needed some water. And I think starting it early is immensely important. Immensely important. Because it's two things. One, try, right? And it doesn't matter. You know, you're 2.5 years away from being year 11. So try it. If you make a mistake, it doesn't matter. If you get it wrong, it doesn't matter. Your brain's just getting used to it. And I always refer back to things like chess and Sudoku. And the first time I learned chess, and I remember it very clearly, it was, you can't see everything. And only when you practice and practice and practice. But we're not going to be doing this every day. So I like to preempt. I like to do things that are quite challenging with Key Stage 3. You're not going to be sitting year 9 SATs, ever. So I want to build these skills that really well for you in year 11. And, for you guys, it sounds like it's miles away. The point I'm really saying is give it a go. All right. All the notes and the intros and balancing from last session are already on there. So what I'm going to do today is really show you how I do it and just focus on that. So what I'm going to do is zoom into this. And one of the things that I see, which is a throwback from primary school, is students working too fast. They just go right like that. And now sit back, relax. Think of it as a chemical oil painting. Okay? You want to enjoy it, look at it, and really pay attention to it. And when I look at this equation, I know whatever I have on, whoopsie daisy, too thick, whatever I have on one side, and let's pick my right hand side, I must have exactly the same on the other. Matter is energy. You can't create or destroy energy. So whatever you had on your left hand side, you have to have on your right hand side. Now looking at the thing, well, hold on there. I'm not starting with my magnesium because it didn't pop out to me. What popped out to me was the oxygen. See, I've got two of them. And remember, you cannot change that number, the formula little subscript 2, right? You can only put a big number in front. It's like saying, well, I have got one oxygen molecule, which is made of 2 oxygen atoms. It looks like this. Well, you can't suddenly put another one across there. It doesn't work that way. That's no longer an oxygen molecule. With 3 oxygens, you're looking at ozone. But anyway, all I can do is say, aha, I want 2 molecules. Dun, dun, dun. Okay, so looking at that, I think, well, hold on there, Ree. I've got 2 oxygens there and only 1 oxygen here. I need 2 oxygens. Well, I can't delete that. So what I'm going to do is I'm going to put big 2 here. So now I've got 2 times 1. There's 1 oxygen there, 2 times 1. 2 oxygens here, 2 oxygens there. Yay, I'm happy. No, I'm not happy. Well, because I've doubled the oxygens, I've also doubled the magnesium. So now I've got 2 mgs. I've got one mg there. Then I'm going to put 2 there. Okay, that's balanced. Right, so next one, I look at it, and again, I'm paying attention to it, and I'm looking at everything. And the thing that pops out to me is Cl2. L2 chlorines. Now, it doesn't matter if what popped out to you was a hydrogen, thinking I got 2 hydrogens, but it really doesn't matter. But let's do this. Look, I got 2 Cl2s. I got 2 chlorines. I've only got 1 chlorine here, so I'm going to put a big 2 here. All right, so let's look at it. What else pops out? Well, my hydrogens have got 2 of them. I have, and if I look, I got 2 times 1, 2 hydrogens here. I got 1 calcium there, I got 1 calcium there, I got 1 oxygen here, I got 1 oxygen. Dun, I am balanced. So when I'm looking at 4, I love 4. I'm going to delete all my notes anyway. So when I look at 4, see, my brain works in a problem-solving way. And I look at the fact that I'm supposed to make the left-hand side the same as the right-hand side. Now, there is the long way of doing it. I'm not going to show you that. I'm going to tell you what I look at. Well, look, I've got an even number of chlorines here and an odd number of chlorines there, right? There's no way I can change this to an odd number. I can't do it, right? And what I mean by that is, and it's a bit of maths, anything in the 2 times table is an even number. So if I put a 3 there, I get a 6. 2 times 3 is 6. If I put a 5 there, I get 10. 2 times 5 is 10. I'm always getting an odd number. I'm not getting an even number. So I don't even bother with this first. I think, I've got to put a 2 there. It might be right. It might be wrong. I don't know. But I've got to put 2, 4, 6, 8. I've got to put a 2 there to make this even. I might turn into a 4. 2 times 3 is 6 chlorines now, because there's my 2 times, it's 6 chlorines. Well, I've got 6 chlorines on this side. Well, I've got to put a 3 there, because 3 times 2 is 6. Now I've got 2 times P, 2 times 1 phosphorus. I've only got 1 phosphorus there, put a 2 there. And it's all this kind of fun thing that you have to do. What I am going to suggest is, and I'm going to be very naughty, I'm going to delete. Right? What I do suggest is that you look at or start with these that we started on last week. Just have a go. 3 aluminium is really tough. I did, shoot a little video on how to solve that one. Give it a go. If you can't, just watch the video. All right? So you got quite a lot. Oh dear, look at that. You got quite a lot to do there, darlings. Okay? The big thing for me is give it a go. If you get every single one wrong, it does not matter. All right? As long as you try. Okay? What am I doing? I'm stopping the recording. Stop.